Today I'm going to discuss about spectroscopy and introduction to ultraviolet spectroscopy. So before starting ultraviolet spectroscopy, it is very important to know about the modern instrumental methods which are used for this determination of structures of various compounds. There are various methods which are used for structural determinations. First method used for the determination of a structure is known as nuclear magnetic resonance spectroscopy. In short form, it is also known as NMR spectroscopy. Nuclear magnetic resonance spectroscopy is very useful for the determination of carbon, hydrogen, nitrogen, sulfur, and phosphorus. Infrared spectroscopy. In short form, it is known as IR spectroscopy. IR spectroscopy is used for the determination of functional groups. Third method is mass spectrometry, which is used for the determination of molecular mass. Next method is ultraviolet spectroscopy and visible spectroscopy. Ultraviolet spectroscopy as well as visible spectroscopy is used for the determination of conjugation of compounds. In short form, it is known as UV-Visible Spectroscopy. Fifth method is X-ray spectroscopy, and it is used for the determination of surface morphology of different compounds. Sixth and seventh method include atomic absorption and atomic emission spectroscopy, and these methods are used for the determination of various elements. Combinedly, these all methods are used for the determination of exact structure of any compound under investigation. Now, next topic is spectroscopy. Spectroscopy is the branch of science that deals with the study of interaction of electromagnetic radiation with matter. So, in spectroscopy, we study interaction of electromagnetic radiation, which is a form of energy, with substance under investigation. So, when the electromagnetic radiation of certain type is incident upon any substance under investigation, it produces a specific spectrum. Spectrum study generates the base of spectroscopy. Now, we will understand spectroscopy by this representation. Now, when any physical stimulus means EMR, which represents electromagnetic radiation, is incident upon any molecule which is under investigation, it generates a response. Detecting instrument detect that response and generates a spectrum. Spectrum is a visual representation of the various structural properties of the molecule. So, study of this spectrum is the base of spectroscopy. Now, electromagnetic radiation. Electromagnetic radiation consists of discrete packages of energy which are called as photons. So, EMR consists of various photons. Now, a photon consists of an oscillating electric field which is represented by capital E, and oscillating magnetic field which is represented by capital M, and they are perpendicular to each other. Now we will discuss about electromagnetic radiation. In this picture, you can see a wave-like structure, this one, and this represents electromagnetic radiation. Here are two waves First is the red wave, and it represents electric field, while the blue wave represents magnetic field. Combinedly, they makes electromagnetic radiation. There are various parameters which are associated with electromagnetic radiations, and these include energy E, frequency N, and wavelength lambda. Now, energy is directly proportional to frequency and inversely proportional to wavelength, and it is indicated by the equation below. In this equation, E is equal to h nu, where E is energy, h is Planck constant, and nu is frequency of radiation. Now in this case, energy is directly proportional to frequency nu, while it is inversely proportional to wavelength because nu is equal to c upon lambda. So if we put this value in this equation, it becomes E is equal to h c upon lambda. So energy is inversely proportional to wavelength. Now frequency N is number of times electrical radiation oscillates in 1 second. Next term is wavelength. It is represented by lambda, and it is the distance between two maxima. In this picture, these are two maxima positions. The distance between these two maxima is known as wavelength. It is represented by lambda. Lambda is a very important parameter in spectroscopy. Now, in this picture, you can see different regions of electromagnetic radiations. These regions are gamma rays, X-rays, ultraviolet rays, visible light, infrared, and radio waves. These regions are of different wavelength and different energy. Some are in longer wavelength region, and some regions are in shorter wavelength region. How we can classify longer and shorter wavelength regions? See here, these are two maxima, and the distance between these two maxima is higher than the distance between these two maxima. So the wavelength region is higher here, while the wavelength region is shorter here. Now there is a huge difference of energy between these wavelength regions. In longer wavelength regions, the amount of energy involved is lower. In shorter wavelength region, the energy is higher. So we can say gamma rays and X-rays are in higher energy region, while radio waves are in lower energy region. While in case of wavelength, gamma rays and X-rays are shorter wavelength side, while radio waves are in longer wavelength side. Ultraviolet region is in between 200 to 400 nanometer, while visible radiation in between 400 to 800 nanometer. Visible light is again further subdivided into different regions, like 400 nanometer, which is represented by purple color, 500 nanometer, which is around in between green and blue color, 600 nanometer, which is yellow in color, and 700 nanometer, which is red in color. Now, why we use ultraviolet spectroscopy? Ultraviolet spectroscopy is used for the detection of impurities. It is also used for qualitative analysis, quantitative analysis, single compound without chromophore, drugs with chromophoric reagent. Chromophore is a group which shifts the absorption maxima towards the longer wavelength side and thus produces a color. Different dyes are the example of chromophore. It also helps to show the relationship between different groups. It is useful to detection in the conjugation of the compound. As I said earlier, ultraviolet spectroscopy is mainly used for the detection of conjugation. Thank you.